Okay, trigonometry. In Math 10, this is going to be the study of right-angled triangles. Okay? Right-angled triangles. And we're going to look at the relationships between how the ratios of the sides are related to the angles. So before we jump right in, here is some notation that you need to be familiar with. This symbol here is called theta. It is a Greek letter. Just like pi is a Greek letter, this one's theta. And it is a Greek letter used to denote angles. Alright, so we use theta for the angle. So what's an angle? Well, an angle is made by connecting two lines at a point. Please don't laugh, you guys. Alright, so we have two lines connected at a point, and the angle is made between them. This is probably something you're already familiar with. Now, just in terms of our notation, this up here, that would be read as angle ABC. Angle ABC. And it's important just to, as an introduction, to understand that where A, B, and C go. So the most important thing is that B goes there. It doesn't matter where the A and the C are, but B is the middle. And that's just a convention that is made. So I think most people might do this, ABC. But ultimately, it doesn't matter where the A and the C are. So that would be angle ABC. The middle letter is the vertex. Okay, so I'm just going to highlight that middle letter. The middle letter is the vertex. B is the vertex. Okay? Yeah, and then that special word that's used for the point, that would be the vertex. That should be pretty familiar. Now, if that's angle ABC, what can we say about the next one? This would be not an angle, but a triangle. Triangle X, Y, Z. And triangle XYZ, there's no convention here. The X, the Y, and the Z could go anywhere. X, Y, Z could go anywhere. However, if I said I want angle X, Y, Z, which angle in that triangle would I be referring to? Angle X, Y, Z would be, yeah, this guy right here. So it's important that you understand that in the language, they're going to be referring to these angles inside triangles with this terminology and these symbols, and you need to just identify the middle letter as the vertex. So that would be angle X, Y, Z. Hopefully that is clear. There are 4 types of triangles here that we need to be aware of. Equilateral, all angles and sides are congruent. Do you guys know the word congruent? What's another word for the congruent? Yeah, the same. And I'm just going to fill in the phrase underneath. The angles of a triangle add up to, some people already knew that, 180. So if you had to divide that 180 into the three angles of the equilateral triangle, every angle in the equilateral triangle would be 60. Good. Each angle would be 60. No matter what size the triangle is, all those angles would be 60. Isosceles, this is what I wanted to name my child, but I wasn't allowed. What do you know about isosceles? Two sides the same. And if two sides are the same, what does that mean for the angles? Two angles are the same. And then scalene is be like any random triangle. All different. So the big focus though in this chapter is the right angle. So I'll just highlight that for you. This is the big focus, the right angle triangle. Sometimes you'll see equilateral, sometimes you'll see isosceles, but you'll have to do a little bit of problem solving to just make the right angle triangle. So the right angle triangle you guys are already aware of. So it has just has to have a 90-degree angle in it. Must include a 90-degree angle. That's it. And of course the 90-degree angle is the square angle. So it has to have one of those, a square angle. That's it. And we're going to focus on right angle triangles pretty much all the time. So this last bullet, the two acute angles. What does acute mean? Smaller than 90 degrees. Good. If I make a right angle triangle, when I'm talking about the other two, these two, I'm talking about this one and this one. The ones that are not the right angle. Okay? So if altogether all the angles add up to 180 and you already have a 90 there, if you subtract 180 or 90 from 180, you're left with 90, right? Those two other angles will then add up to 90. The missing 90 are going to be those other two. Okay? Examples could be like 30 and 60, 45 and 45, 50 and 40, 20 and 70. You okay with that? So when we're doing our right angle trigonometry, we typically will focus on these guys. We don't use this one in Math 10. So we'll be focused on either this one or this one. Those other acute angles in the triangle. Some more vocabulary that you have to be aware of. These are angle of elevation and angle of depression. You have to know these. And then in brackets there, it could also be these fancy words that I never use. Inclination or declination. Like, I never use those words. And most of the time it's elevation. Most of the time you're given the angle of elevation. Sometimes you're given angle of depression, and it throws off most students because occasionally this one is ignored when people study. So you might remember parallel lines from junior high, and with parallel lines you would have something called like a transversal that cuts through. I don't know if you guys remember that. This is called a transversal. Some of you that might have taken like Math 10-3, which is kind of, there's some review from junior high in there. This parallel lines in the transversal, if you recall, what do you know about this angle and this angle? Yeah, they're the same. They're equal. So right away you can see that the angle of depression angle of depression is equal to the angle of elevation. So before you even know what they are, they're equal. Okay, that's something you can remember. So by definition, I would use this picture. You need a horizontal line. So here I am staring at the door. If I was to draw a horizontal line from my eyes to the door, it would hit the sign, my sign with my name on it there. So the angle of elevation would be from the door up to the clock. And angle of depression would be from the door down. Okay, so it's always drawn from the horizontal. So you can include that. Draw from the horizontal. So depression, you could probably associate that word with like feeling down. I'm feeling depressed. I feel down. So that's down from the horizontal. Down from the horizontal. Whereas elevation, you could probably associate that word with, oh, I'm feeling good. I'm feeling elevated. I'm feeling up. I feel up. So there it is. Angle of elevation, angle of depression. Okay, so let's just draw a quick triangle. It has to be right angled. Draw the right angle in the corner. This angle in the bottom, does it go up from the horizontal? So we call that the angle of elevation. Now this is what everybody does, and they get it wrong. They call this in red the angle of depression. That is not the angle of depression. That's the most common mistake. So this is not the angle of depression. And who cares what they're called, right? But when you're doing a word problem on your own during an exam and they give you this vocabulary, you have to know what they're talking about in order to label your triangle properly and get the answer correct. The angle of depression would be from a horizontal line. So I'll draw it in green. Green is a nice color. Makes you feel good. This is the angle of depression. Maybe I should put it in purple. Sad or something. Whatever. Angle of depression is equal to angle of elevation. Alright, so remember that. And if you forget it after Math 10, that's cool. But remember it for now. The trig, however, you got to know that for Math 10, Math 11, and Math 12. Trig will show up everywhere. Trig is one of the most powerful things actually in math because angles are seemingly connected to all these different topics. Okay, some terminology for the triangles. Remember I said you only ever work with the two acute angles? So these are the only two possible ways that you can label the triangle. First of all, you know the hypotenuse. Do you agree? The hypotenuse is always straight across. So step one, find hypotenuse, which I will call HYP. Find the hypotenuse. It is across the 90. I would just start there because you know the hypotenuse. It's the longest side. It's across the 90. You remember it from junior high. Start there. Now you only have two labels that you pretty much have to worry about. If you can find the hypotenuse, which is across the 90, you can find the opposite side, which I'm going to call OPP. So where would OPP be? Well, if I'm going to work with angle A, then this is the opposite side. Now if I work with the angle, and don't write this, but if I work with the angle up here, then that's the opposite side. So opposite and adjacent, these terms that you're going to have to use, They're relative to which angle you're going to work with. Okay, so find the opposite by going across the angle you're going to work with. And I'll put across angle of interest because that's the one you're interested in. And then, like, if you've already labeled hypotenuse and you've already labeled opposite, you just have to fill the ADJ. ADJ will be adjacent. Adjacent means beside. So do you see how this adjacent is beside angle A? See how it's right next to it? Adjacent is beside A. The hypotenuse is also beside A, but the hypotenuse is the hypotenuse, so the adjacent is the adjacent. So fill adjacent, there's only one side left. Anyway, there's only one side left to fill. So let's use my pointer and let's just talk about these steps one more time. First step, find the hypotenuse, which means I got to find the 90 and go across. Which angle am I working with? Angle A. Angle A is up here. What side is directly across angle A? Down here. Call that opposite. There's only one side left to fill. Call it adjacent. We need to be able to do that. That is critical. The next step is to show you trigonometry. These are called sine, cosine, tangent. You can find them on your calculator, I'm assuming, by looking for those abbreviations. Sine, cosine, and tangent, which are abbreviated to sine, cos, and tan. So don't say sin. I'll get very mad at you. And don't say cos. I'll get very mad at you. It's sine. And sine's companion, the cosine. And then this guy off on the tangent. He's just crazy. He's off on his own. Sine and cosine are very much related. Look what they both have in common. What do they both have in common? The hypotenuse. They're both a ratio including the hypotenuse. The sine will deal with the opposite side, and the cosine, his brother, will deal with the adjacent side. But they're both related by this hypotenuse. But the tangent, he's sort of on his own there, and he doesn't have the hypotenuse. He just does the op and the ADJ. This is an acronym that most people who go through high school, that's one thing they'll remember. SOHCAHTOA. SOHCAHTOA. Say it. SOHCAHTOA. SOHCAHTOA. So why is that important? Because SOH, SOH, Ka, CAH, and Toa, TOA. SOHCAHTOA. You don't even have to memorize anything if you can remember SOHCAHTOA. Okay, for these formula, the left-hand side, you guys understand LHS, left-hand side? It's called a function, but we'll talk about that later in the course. Trig function, sine, cos, tan. You find that in your calculator. Trig function applied to the angle. So really I could put sine theta. Do you guys remember that? Theta is for the angles. Cos theta. And the last one would be tan theta. Okay? Now what's on the right-hand side? What's on the right-hand side? A ratio of sides. in a right angled triangle. So for these equations, it's always going to be like this. Just so you can always remember, left-hand side, it's going to be sine, cos, or tan with an angle, theta. And then the right-hand side is always a ratio of two sides. Okay? And depending on the angle, the ratio changes. So if your angle's 30 degrees, your ratio is different. If your angle's 60 degrees, your ratio is different. Okay? So the angle is related to the ratio of sides. Here, I'll give you an example. Look at that picture. What angle is this roughly? Do an estimate. Is it somewhere like halfway between 90? Halfway would be like this, right? So it's less than 45, half of 90. Do you want to say this is like 30? Let's say it's 30. Then I can guarantee you there'll be some ratio like this. Sine 30, which is the opposite divided by the hypotenuse, it's always half. If you have a 30-degree angle here, the ratio between the opposite and the hypotenuse is always half. No matter how big it is, it's always half. Okay? If your angle's 45, is that ratio of sides going to be different? It is different. This ratio of side to this side is going to be different just because of the angle. What about a really crazy one like this? Look at the, if this was our angle, the ratio is much different. So depending on the angle, you'll have different ratios. Okay? All right. You got room on the bottom here, you guys? I just got to do one thing and then see if this gets better. Okay, draw a triangle like this. Where should we put theta? We know 90 is down in the corner. Where should we put theta? Does it matter? You got two choices. Where do you want to put theta? The bottom? Okay, let's do that. Let's put theta down here. That's the side we're interested in. Let's just make up some letters that we're comfortable with. A, B, and C. You probably are comfortable with that, right? Why? Pythagorean's theorem. You're comfortable with that. So let's go and do this first one. How do you say that one? Sine. Good. So this sine of theta, what's that going to equal? Who said that? A over C. Why? Relative to angle theta, how would you identify side A? Op, hype, or adj? This is definitely the opposite side relative to A. Do you agree? I skipped step one. What was step one? Hypotenuse. This guy's right across from the 90, right? So then you only have one spot to fill, which is that bottom side, which we'll call the adjacent, ADJ. So now we can fill these in. Sine theta would be A over C. Left-hand side is some trig thing in my calculator with an angle. And the right side is some ratio of sides. In this case, A over C. What will the cosine of theta be? B over C. Excellent. Got one person whispering. That's good. Don't be afraid to yell out, you guys. I like it. Tan theta? Yeah. What'd you say? Beautiful, man. A over B. Beautiful. And those are the formulas. That's all you have to do in this whole chapter. Over and over and over again. Some of you in Dash 3, you're probably like, I've seen this, right? If you've taken Dash 3, I've seen this before. So that's nice. You'll see trig in Math 20, and you'll see trig in Math 30. You'll see trig in Calculus. Okay? We are only going to start with the tangent ratio. I could start with sine. I could start with cos. It doesn't really matter. We're just going to work with tangent solely because that's what the textbook does. So I just want you guys to be chronological order with the textbook, and that's what we're doing. Do you guys remember the acronym for tan? SOHCAHTOA. So it's going to be tangent theta. Tan theta is equal to op divided by ag. That's all it is. Tan theta is op over ag. Wait a minute. In the last diagram, the adjacent was on the bottom. Okay, now you're just lying to me, right? Good. No, because now we're interested in this angle up here, and if you go straight across that angle, then this is correct. That is the opposite side. Find the 90, go straight across that. That is the hypotenuse. So you only have one spot to fill, which is the adjacent. So you really need to be good at labeling. You have to label. And then you can do the trig ratio. I'll show you the algebra. It's just cross multiplication, and then life is good. All right, determine the tangent ratio. What is the tangent ratio? O divided by A. We can do this. We are smart people. Which angle am I interested in? 23. Therefore, x is going to be labeled op. And find that 90, go straight across, that's the hype. Notice nothing is up there. I don't know what hype is. That's why I'm going to use the tangent. I fill ADJ because that's the last spot to fill, and now I can find the tan ratio. This will be a test question. Find the tan ratio. And all you have to do is find that ratio. Tan 23 is equal to, and this is what you'd be looking for in your multiple choice test. What's the tan ratio for 23? X over 5. And some of you already know how to solve x. Guarantee it. How would you find x? Multiply by 5. So 5 multiplied by tan 23, and you'll get x. But right now, all we're interested is this ratio. That's all we care about right now. I'll show you how to solve with your calculator in a second. Okay, so next one. Before you do anything, just label. Okay, hype. Okay, hype is easy to do. It's across the 90. So now here we go. Is 12 op or ag, and why is it op or ag? Y is op because we're worried now about angle 16 there. So this is op. This is ag. So now I can say tangent 16, some trig thing with an angle, is equal to my ratio of sides. Which ratio do I care about here? Y over 12. So that would be what the solution to this question. Find the ratio. You guys feel okay? It's Friday. You're learning trig. It's not too hot in here. Beautiful, beautiful. Look, and there's the assignment. We're almost done. Hallelujah. Amen, brother. Right? Okay. Hands up. I have a calculator. Hands up. I don't have a calculator. Come get one, you guys. Yes, bring me something. I'm just going to throw this video on pause. Okay. Let's take a look. Let's solve these problems now. All right. So to solve these problems, if I wanted to actually find x, what you can do, on this side you can put a 1 underneath. And now we can cross multiply. Do you guys remember what to do on cross multiplication? You always times the two that are actually numbers. Tan 23 is just some number that's going to get pumped out by your calculator. And then you always divide the thing across x. So it's tan 23 times 5 divided by 1. In a sense, you guys know this though, if 5 is downstairs on the right, it needs to go, upstairs on the left. So to solve this, it would be 5 multiplied by the tangent of 23, and that's going to equal x. Okay? So like what you could do is hit tan 23, hit enter, make sure you figure out what that is, and then times by 5. So you should get 2.12. If you have some problems with that, then you're not in the wrong mode. Or you've typed it in improperly. It's because your calculator sucks. 23 tan, then times 5. Okay, let's try this one. 12 multiplied by tangent 16 is equal to y. Okay. Tan 16 times 12. 3.44. If you don't have 3.44, put your hand up, I'll come see you. If you can't get 3.44 to show up. Everyone can find that 3.44? Okay. Okay, that's solving for sides. Okay? So just so everyone's clear, the first thing we did was find ratios. The thing we just did was find a side. And there's only one other thing that could happen. Find the angle. Those are the only three things that are ever asked of you. Find a ratio, find a side, or find an angle. That's pretty good in math for a chapter. I only have to worry about doing 3 things. Amazing. Finding sides is all about cross multiply. I can cross multiply, I'm good on that. Finding ratios is all about labeling. If I can label and remember SOHCAHTOA, I'm good there. And then finding angles, you just have to use these versions of the buttons. Those are the second feature buttons. Because they're like inverse functions, which we will not talk about now. They're in the second feature. And you can find them highlighted in maybe a different color just above the button. So you see the word sine, and then sine with the power -1. Cos, cos with the -1. Tan with the -1. And that's not a power. It's just a symbol for inverse. So it's not a power. And it's really confusing for people just learning math. So this is just a symbol for inverse. And whenever I say inverse, you can just think to yourself, oh, the second function. The second function. Like what, in Pythagorean theorem, you know how you have x squared is 25? How do you solve for x? You square root? What's the second function for square? square root. Okay? All right, so let's go down here. All right, so let's take a look at this triangle without even reading anything. Where's the right angle? Down here, hey? Okay, so that where it says solar panel, that label would be? Good. Now let's go figure this angle down here. Let's just find that one. If we're going to work with that angle down there, 208 would be the up. And 70 would be the adjacent. Good. Okay. SOHCAHTOA. All right. SOHCAHTOA. This is in your head. SOHCAHTOA. Look at that triangle. What information do I have? Do I know anything about hype? I could find it with Pythagoras, but I'm being lazy. I don't want to do Pythagoras. So if I don't know nothing about HYP, I can't use that one because it has H in there. And I can't use that one because it has H in it. So the only one I could use is TOA. I write the formula down because I'm smart. A lot of people think they're smart by being lazy and not writing the formula. How did you get here today to this building? What'd you drive on? What'd you walk on? Roads and sidewalks. If the structure is there, you can use it. If you write the formula, you can use it. So, right now, could I fill anything in there? Yeah. Tan theta is equal to 208 divided by 70. What don't I know? The angle. To find the angle, you got to use these buttons. And I'll just show you why. It's like, don't write this. If I had x squared is 25, how would I solve for x? I would have to like do square root, right? So that's something that's going to happen like what's the opposite of tan? Could I divide by tan and maybe the tans will cancel? No, you can't do that. So what's the opposite of tan? Well, tangent inverse. So you go tangent inverse and those cancel. What I do to the left, I got to do to the right. So tangent inverse. That's what you're doing. All right, and I can demonstrate that on my calculator. So I would go second function tangent, and the number was 208, right? And 70? So it's 71.4 degrees. If you got a crappy calculator, do 208 divided by 70, hit enter, and then go second function tan. If you have a crappy one, do 208 divided by 70, hit enter, and then go second function tan. So I know it's 71.4. Theta equals 71.4. So that goes right here. And then because I'm so smart, I'm a Math 10 student who pays attention, I can go 90 minus 71.4, which is what? 0.6 would get me to 72. 18.6? Okay, I suck at subtraction. 18.6 degrees is the angle up here. Because they all have to add up to 180, right? Yeah. Any questions about that guy? We got one more to do, and then you're free. Okay, here we go. Determine the measure of K. Where's K? Down here. Go straight across K. That would make 9 the op. Find that 90. Go straight across that. That's the height. And therefore 13 is 80J. Sokatoa. Sokatoa. No? So you write that down, or you're just thinking of this in your head. 13 is adj, 9 is op, and I don't know jack squat about hype. Can't use that, can't use that, have to use TOA. Alright, here we go. Tangent of theta. In this case, could I just use the letter K to replace theta? K is the angle, right? Alright, now the ratio of sides on the other side. Op over adj. 9 over 13. To solve for K, I got to get rid of that tangent. Inverse tangent 9 over 13. Inverse tan. 9 divided by 13. I got 34.695, so 34.7. Then I can go n is equal to 90 minus 34.7, 55.3. Okay, here's 34.7. Here is 55.3. The homework is on the bottom. We'll mark the quizzes on Monday. Study your measurement this weekend.